Okay, welcome everyone. This is week 7 lab session, and I did give you 2 SQL projects to work on. One on subquery, and there's another one on stored procedures. So let's begin with the first one. I'm going to begin with the one on subquery. I think it's just 2 questions we're going to go over, and then we're going to move to the stored procedure one. So in this session, we're going to be using the AdventureWorks 2022 database. The next thing we're going to do is read question 1. It wants us to use this table. So when you see something like that, you can just copy and do a select star from the table so that you get to explore the table you're going to use for the analysis. So I'm going to use, just put down that table and we're going to execute to explore. So this is a salesperson table in the sales schema. We have business entity ID, territory ID, sales quota, bonus. All of these columns, you can actually check their definition in the data dictionary. I think that's a document we're supposed to always bring forward. Let me see. Most likely we can see that in lab 6 data dictionary. I'm just going to copy this and bring it forward. Let me just open. So if you need to consult more information about those columns, you can always find them in this data dictionary. First thing you need to do is identify the table. We're looking at the salesperson table, and the schema is a sales schema. So I'm going to go, the data dictionary begins with the schema name. So I'm going to identify sales first. So when I get to the sales portion, I'm going to switch now to the salesperson table. So it's easy to look up any table, identify the schema on the data dictionary, and from there start looking at the table, which is on the next column. So this is a sales schema begins right here. The table of interest is the salesperson. So I'm going to go to this side and start looking at salesperson. So salesperson right here. So the very first column on salesperson is the business entity ID. Last time we did check this column. Next is a territory ID. So you can just read this information to get a better understanding of what's going on. We're going to be dealing with this column right here, the sales quota, the projected yearly sales. So on this table, we have the sales quota. This is the projected yearly sales. We also have the sales year to date. That's sales total year to date. All right, so let's go back and read the first question. With those definitions, we should be able to understand this question and answer it nicely. So how many sales people are meeting their year-to-date quota? So if I just project that table, we're talking about sales year-to-date quota. We have this. This is a sales, the individual sales year-to-date, and then this is a quota. So this is what they expect you to get by the end of the year, and this is what the salesperson is actually getting. So this is the projected value, and this is the actual value. So if you read this question, how many salespeople are meeting their year-to-date quota? So this is the year-to-date quota projected by the business, but this is actually what the salespersons are generating. So if you are actually hitting your sales year-to-date quota, then your actual sales year-to-date quota has to be greater than the sales, the expected or the targeted. See, so you're just simply going to be adding this condition where this is greater than this, and then we're going to count the number of salesperson, right? So it's like you get hired in a company like a sales agent. They give you what the projected or the expected sales quota you have to meet by the end of the year. Now, this is your actual sales values, right? Now, if you compare the actual to the expected, those whose actual is greater than the expected means they are actually meeting their quota expectation. See that? So if you go back to the dictionary, you're going to see is a comparison between this. This is projected yearly sales, right? And this is this column right here. That's a projected value or the expected value. Then the actual one is this. This is this particular sales individual has generated this in sales amount. This is actual stock value, right? So this is a sales total year to date, right? So we're simply going to be comparing those two values. And let me show you how you do this in a normal environment before we now force ourselves to use the subquery approach. So in a normal environment, once you have this, you're simply going to add a where clause. So that's the exploration right there. The where clause in this case will be comparing those two columns we've talked about. So take the actual sales value of the individual. And this is the sales year to date, this one. And if this value is greater than the quota expectation, which is this one right here, this one, then that person is actually meeting their year-to-date quota. So take their actual value and compare it to the quota. If the actual is greater than the quota, then you're meeting your target. So this is your target. So if what you acquire is greater than your target, then you're actually meeting your target. So this is it right here. So if you notice how many salespersons are in this table, there are 17 salespersons in that table, and how many are actually meeting their target? 14. See that? So this is the count we're supposed to do. How many salespeople? So it's a count of their business entity ID. All right, so you just need to transform this now into a count. Count. The best way to count this salespersons is business entity ID. Remember, in this table, the business entity ID was the primary key for salesperson record. So each salesperson has a unique value on this. If you want to count the number of salesperson, you do a count on that primary key column. So this will give you the total number of salesperson who are meeting their year-to-date quota. That's at 14 we saw on that table. But this is not what they wanted us to do. The idea is valid, but they want us to do this in a query environment, an inner query or subquery environment. This is something we're going to do next week. Right? The ones we've studied are the ones that we just put in the subquery on the where clause. Like the next question we're going to do. So this is one way to do this. If you actually want to solve this in the way it was asked in a subquery environment, this part right here, inner query or subquery, then that's the concept of a derived table. That's what we're going to see in the next week. So you simply extract this information. See that? This is the list of all those salesperson whose whose sales year to date is greater than the sales quota. These are the list right here. And then if you want to proceed to count, this is something we're going to see next week. You simply have to target this and make it a subquery like this. Right? And then you make sure you give it a name. For example, T1. So this table right here, we are storing it in a virtual table called T1. And now we can do a select star. Select star. I'll come back to this concept. This is what we're going to study next week. You see, let me indent this. Our query has become a table. This is the same as saying select star from T1. But what is T1? We don't know T1. You see, T1 is now useless if we don't define the query that builds T1. See? So if I back up a little bit, if I keep it like this, you understand what this is all about. But T1 is a query, and this is the query called T1. This query runs and generates a table, and the system is calling this table T1. This table is the list of people who fulfill that condition, whose sales value is greater than the quota expected by the company. This is a table called T1. Right? You see, so we can now go above and do a select star from that T1. T1 is built from a query. This is what we call a derived table. This is the focus of next week. I bet it's easy. Right? This is a derived table. A derived table is a subquery. This is a subquery which is placed in the from clause of an outer query. There are two queries right here. There's a select star from, and there's an inner one right here. So this inner one is generating a list of those salesperson whose sales year to date is greater than the sales quota. This condition right here. And all of those individuals are put in a table called T1. Right? And then now we go above and do a select star from T1. So the next logic is this logic we're going to apply. I'm going to dismiss asterisk. So once we've built this table and store it in T1, go now and count asterisk from T1. Count business entity ID from T1. So if I dismiss all of this, this is just a simplified version. But what is T1? T1 is a query I just dismissed. So this is how you can remember T1 is holding all those individuals whose sales year to date is greater than the sales quota. We have stored them in T1. And now we're going to T1 and we're simply counting the number of those salesperson who qualify inside T1. What is T1 here? If I run this, remember this has to fail because there is no table called T1 in this database. Execute, it fails. So we need to put the query which defines T1. This is it. So you define something, you capture it, and then you go above it and add an extra logic on it. And that will be the focus of next week. I don't really expect you to, but this is an easy thing to visualize. Now it's kind of strange. So you can actually do a select star from a query. The answer is yes. And that concept is called derived table. See that? But then this is an easy way to solve that question. On the same query, you capture the information with a where clause and you just count. See, hit the target right here. There are 14 salesperson whose sales year to date is greater than the sales quota. Remember, the question is how many salespeople have this greater than, no, not that one. We're going to go to that. How many salespeople are meeting their year to date quota? You have to take their individual sales year to date and compare it with the quota from the company. And then we can stay on that same query and do the count, 14. Another way, if you want to use a subquery, you capture the information separately. First, target a list of salespersons whose sales year to date is greater than the sales quota. This is a list. There are 14. And if I go now outside the outer query and do a count of the business entity ID, this is a column right here. There are 14 of these. So if you now put everything together, highlight, you get 14. But this strategy, we've done in two parts. We first of all, extract the correct number of records that fulfill that condition. We store them in a virtual table called T1. This is virtual, it's not stored in the Object Explorer window. See? And now we can proceed outside and do a select star from a select count business entity ID from T1. What is T1? T1 is a query we define inside. That's the inner query or the subquery. Right, this is very important. I'll come back to this detail. This is the strategy in SQL that helps data analysts a lot in the industry. You have to know this. Right. So this is a simple way, straightforward. It's another strategy using an inner query. I'm talking about this because we're asked to use it. I just want to introduce you to something we're going to do next week. Now, but what you and I can do is a B part. How many salespeople have year-to-date sales greater than average sales person year-to-date sales? There's an unknown to this question right here. If you go back to this table, so I'm solving now the B. So this is A. I don't expect questions from you for the A part. All right, this part right here is sufficient for now. The second option 2, which is this one. So this is option 1. I expect everyone on the call to identify and be able to solve this question using option 1. For option 2, we will see this next week. The focus of next week will be derived tables. When you take a subquery, this is the subquery, and you put it on the from clause, it constitutes what we call a derived table. So I don't expect questions on this for now. Next week we're going to get to that. So this right here answers this question, but then without the use of an inner query or subquery, right? So this is a strategy. Let's go to B. I expect you to now focus closely on B, because we can use a subquery to solve question B. Right, so this is B. B wants us to investigate how many salespeople have year-to-date sales greater than average salesperson year-to-date sales. If you look at the table we are exploring, it's just one table in this question. Nothing is reported about the average year-to-date sales. We are given the year-to-date sales. This is a column right here. That's what is referenced in that question. How many salespeople have year-to-date sales greater than average sales? In fact, this will be the average year-to-date sales. We don't have that information on this table as a column, so that is the missing part in that question that needs to be known. So we're going to use a separate query to solve that part. Remember, that was a strategy we've been using in subqueries. When you spot a question with a hidden agenda, right, this part has not been computed. It is not available on the table, but we can use this to compute it. This is basically averaging all these values. That's what they are referring to right here. So we are looking at those salesperson whose value, whose sales year to date is greater than the average. How many people are performing above the average? That's basically what we're investigating right here. But that average value has not been provided. Can we calculate it? Yes, we can do it. So we're going to use a separate query to calculate that. All right, this has been the target, right, the focus of the sessions over the weekend. So this is pretty much the average year-to-date sales. You have to use this function to get that. Oops. Right here. So you're just simply going to be averaging this column. See, this is it. Sales year to date. Right. Do we know this first part mentioned? How many salespeople have year to date sales? We know this. This is the column right here. The year to date sales, this is it. Sales year to date. We know that part. So we have that. What we are missing is this. To average that, we don't know this. But can we calculate it? The answer is yes. So that's the first thing we're going to calculate. Right. I'm just going to copy that table, put it right here, and then transform this into that average right here. Right, and this will constitute what? The average sales year to date. So that's a missing part in that question. Right, we need to know that part. I'm just going to put it right here. This is the average year-to-date sales. I'm just going to dismiss this to keep it simple. Right, this is it. That's that average value. And all we need to do now is to take the sales year-to-date and compare it to this average. Right. So now, if we want to combine it, we have the parent query, which is just simply going to be based on this. This is the parent query, and how are we going to connect the parent to the child? Through this is an example of a subquery, which will be placed on the where clause. Where, so see what we're going to be doing. We're going to be taking these values in this column, and we will be comparing them to the average, which is this, which we've calculated. This is very important. Right. So give me the list of those salespersons whose year-to-date sales is greater than the average year-to-date sales. And there's a calculation. We don't even need this. This is a calculation. You don't need to put the alias. This is a calculation right here. Right. And remember, subqueries was a strategy to include a subquery. You must put that in a set of parentheses. And then indenting helps. It doesn't mean it's part of the syntax, or it just helps to visualize and understand. So for a better visualization, I always like to indent the subquery so that you can easily understand what's going on. Maybe I even take it to the next line. Right. This helps, right, and highlights so that you can easily understand what is. See, this arrangement makes more sense. Right. So this is us investigating those sales persons whose year-to-date sales is greater than the average year-to-date sales. In the original table, there was no average. We've computed that average from this column. And now we're comparing the individual year-to-date sales to the average. I want to show only those salesperson whose year-to-date sales is greater than the average. What is the average? This is it. It's calculated from this query. This is what we call an inner query, or a subquery, or a child query. And this right here constitute the parent query, or the outer query, or the main query. Now combining these two, we deliver these are the 8 salesperson whose sales year-to-date values are above the average. I want to stop right here for questions. Let me go back to it all begins by you understanding the business requirement. That's where everything begins. How many salespeople have year-to-date sales? This column is available. Year-to-date sales greater than the average salesperson year-to-date sales. The average was not provided. That's where we started. Right? The average was not provided. Right? We had a question mark on that. This right here. This is just simply averaging on that column. This column is available. And that's the first thing we do. We average that, get this value. And last time we discussed, we can just copy this value, dismiss everything, and put this. This is a static way of doing it. Each time you need to go fetch that average and you plug it in there. All right, so this is static. You want to make your code dynamic. It still delivers, you see. But you see, this is going to keep changing. So at every time you need this value, you have to compute it and then you paste it, copy, paste, compute, copy, paste, just like that. But if you put the query behind that value, you're doing a great job. This is dynamic process. At any time, it's going to compute the value itself by running this query against the database, fetch the updated average, and then just pass it to the outer query, and the outer query now filters and delivers the final result. Questions? Remember, it does not end here. This is not the output they want. If you go back to the question, it's how many. This is a count. Right? We've just succeeded to extract all those who qualify, all those whose sales year to date is greater than the average. This is the list right here. The question did not want us to submit all these columns, right? A count. So a single value is expected. How many salespeople? And just like we did in the first example, counting salespersons, we can use the same logic. Salesperson, we're dealing with a salesperson table. Each salesperson has a unique business entity ID. What's the best way to count the number of salespeople who qualify or meet this criteria? Just target this and count 1, 2, 3, 4, 5, 6, 7, 8. And that's what we're going to do. Replace the asterisk and put the count right there. Execute it. Okay. And this right here is the number of sales person. Let me share this query so you can take a look at. I'll give you time to check out this and make sure you understand. Run the inner one, know what the inner one is investigating, the average sales year to date. And then that's the value it passes out to this. So this is comparing where the sales year to date is greater than this value. Right. And after doing that, we are showing the count of, right. And that's how that query concludes. Okay, are we ready for the next question? Please, you have to create time and go over this. These are very important questions. Okay, let's go to the next part, question 2. So run this statement before proceeding. This is there's a statement right here. I'm just going to copy this. All right, some companies, when you see V right here, you're dealing with a view. Some people use TBL for a table. So this right here is just an indication that this is a view. This is not a physical table, right? And maybe the question is going to mention that. So this is where we're going to begin. Again, we are still on the AdventureWorks 2019 database. So for us to begin this question, we need to execute that view. All right, and just copy that, run this. So this is what we have. Okay, this is still running. So while this is processing, we're expecting to get This is 290 from 2019, and we are dealing with 2022. And you guys update this. I forgot to update this. So in 2022, you're gonna get 296 number of rows. 296. All right, let me update that. All right, so there are only these employees ops. And just a moment, let me go back. This is the wrong stuff. Stay on that 290. So this right here, employees in AdventureWorks database. So this is based on the employees table. All right, this is a view, employee department history, but this right here says there are only these employees in AdventureWorks database. All right, so we need to run another table. So if I go to AdventureWorks right here and go to tables, let's find out if there is an employees table in right here. The employees table, it's in the human resources schema. So let's execute a select star from this table and compare to confirm this 290. That's it, something we have to do. I'm going to copy this part. So the one above is a view. This one right here is a physical table. So we went to the tables folder. This is it. I can just drag and put right here. Right. So this right here is a physical table. And it confirms the 290. So on the physical table, we have the 290 employees. So let me make this distinction. Right here, we have a table. This is a physical table. We saw this in the tables folder. And these are the number of employees we have. You can confirm that upon execution of this, we have 290 rows. And this is the employees table. So 290 employees. This right here is a virtual table. AKA views. So this is what we call views, virtual table or view. And in this, the number of came to 296. And remember, this is tracking the employee department history. So 296. Okay, now we've put some things together. Now let's go back. So however, in the view above, so this confirms that this thing you see right here is a view. In the view above, there are 296 rows of data. And that's exactly what we've documented right here. So the virtual table of view, which is this one, has 296 rows of data. Right. So these things are important to gather this information so you can build your strategy around what you know or what is provided. Now this view is created from 5 tables. You and I know how to go investigate the query behind this view and check to see the 5 tables. I think that's one of the questions. You can use those 5 tables to help you answer this question. All right, so let's look at the very first part of the question. Script out the code used to create the view with name human resources v employee department history. So this is a view, and this is found in the AdventureWorks 2022 database. So can somebody help us? How can you script out a view? What did we say in class on scripting of views? Can somebody give me the steps? Step 1, you have to go to the Object Explorer window right here. Step 2, you have to locate the database, which is this AdventureWorks. Right. Next step, you have to expand the database. Right. Next, you go to the views folder. Find the name of that view. This is the view right here. The name is V Employee Department History, which is found in the Human Resources schema. So this is the views is a list of all the views in AdventureWorks 2022 database. And if you just go down the list, these things are in alphabetical order. You're going to see right here. This is the employee one, V employee, V department. This is the one we're currently exploring. This is the name right here. This name right here matches this one. So this is the view. So once you locate the view, what do? You right click on it and you go to script. This is how you script an object in SQL Server. We discussed this in class. Let me repeat this again. I want you to understand the basis of this question. Right? This was just to test your knowledge on that. So script out the code used to create the view with name this. You see, this view we've explored right here. Show us the code that was used to build this view. This view was probably built before you joined the company. Right? Now you're in the company, you're analyzing this. You want to see the code that was used to build that virtual table as a view. Easy. It all begins at the level of the Object Explorer window. Go to the databases folder, expand, target the database of interest. This is it, expand. You're going to the views folder right here, expand. Now find the view in that views folder. The name of the view is this, and this is it right here. V employee department history, which is in the human resources schema. This is it right here. The next thing you do is just right click on it. And once you see this script option right here, you move to create, put this on a new query window, and the rest is history. The system is going to build the code that was used to create that view. And in the business requirement, we're told there are 5 tables that we put together to create that view. Once we have access to the script, we can inspect and see those 5 tables ourselves. Right. So this thing is very important, right? Right. The system we just put, these are just system level information. These ones are not important. The main stuff is right here. See the code, create view. This, you see that name, and this is the actual code that was used to create the view. And if you scroll below, you can count the number of tables by simply counting the number of joins. 1, 2, 3, 4, plus 1. 5 tables. And that's how it was mentioned in this. In the view above, there are this. We've confirmed this information by doing a select star from this view. 296 rows of data. And then this one has been confirmed by scripting out the view. You can only confirm this. We confirm this by doing a select star from the view. Views are just like tables. You can run a select star from them. And you check the number of rows returned is right here, 296. So 296 rows of data from that view. This has been confirmed. How can you confirm that there are 5 tables in that view? You must script out the view, like what we've done right here. Right, you can count the number of tables yourself. This is a table, first table, 1, second table, 2. Right, you see this one is more complicated to count, but if you just trace the joins, number of joins plus 1 gives you the total number of tables. Total number of tables minus 1 gives you the number of joins. If there are 5 tables, you need 1, 2, 3, 4 joins, n minus 1. So if you count 4 joins, add 1 to get the number of tables. Right, you can actually list out the tables. This is 1 right here. This is another 1. From here, this is 3. With this alias, that's 3. This is 4 with this alias. And this is 5 with this alias. So these 5 tables were put together. This table is tracking the movement of the employees across the departments. Employee department history. See that? So why this one is showing you just the current employees. Let me go back to this right here. This is the employee table showing you the current employees. There are 290. Why is it that the history one, the department, the movement one is giving you this? So maybe one particular employee has moved 2 or more than 1 time in the company. And so this history table will capture all that. you cannot see multiple employee IDs. Was a key column right here, business entity ID. Each employee has one business entity ID. But if you go to the history table, you can see repetitions of the business entity ID. That explains why this is 290, which is the tracking the exact number of employees in the company. You cannot have two or more employees showing up with the same business entity ID. Right. So this is, I want you to understand that from a business perspective. The history one is showing the movements. You hire the movement within the same company. Maybe you change department, you have another job opening in the same company, different department, you move to that one. So a track or a record of all your movements in the company will be stored right here. So this is already guiding you to understand why this has 290 and this one has 296. It means that you have possibility of seeing an employee who has had one or two movements, department changes in the company. All right, this is just giving you background information, and I will show you how to investigate that. See that? All right, so I think we've dealt with this one. Script out the code used to create the view. We name this. This is very important. You can also script out the query that was used to build the employees table. It is not just views, but any object you see right here, you can script it out. If you want to script out a table, of course, the process is the same. Target the database, go to the tables folder. Please stop me and ask questions. This is very important. If I want to script out the employees table, this is it right here. I'm going to right click and go to script. You see it identifies as a table. Script this table as, put it on this new query window. The system is going to build the script. The last phase of the training will be in this regard. We're going to show you how to build tables. Right, that's one objective that I need to go through with you guys. Right, we just started off with the select statement. We're analyzing data. We don't know where they're coming from. It's good you have a project where you build a series of tables, insert data into the tables, create a database yourself, and then solve questions based on the database you've created. I've shown you some projects on LinkedIn. We have to target that and knock that out. See? So this idea of scripting is very important. This is taking forever to load, but anyway, just be patient. It's definitely going to load. So it is generating the script that was used to create that employees table in the human resource schema. This should be faster at your end. I think just you guys should go ahead and do this. So just go to Adventure Works 2022, expand the database, go to the tables folder, expand, identify the employees table in the human resources schema, right click on the employees table. You'll see the script table as, click on it, go to the right hand side, create, and then put it on a new query window. Like this, my copy is taking forever to load. I need somebody to volunteer and do that for us.
I don't mind, so I can.
Okay, Alex, you're gonna do the employee one, and then Lanita, I'm gonna come to your screen. You're gonna do the view department history one. So let's begin with Alex.
Which exercise am I supposed to do?
No, I just want you to script out the view, the script that was used to create the employees table. So the view.
Okay, that's fine.
The script to create the employees table. Yeah. So first of all, locate the table on the Object Explorer window.
Yeah, sure.
No, you can. Oh, okay. What's Okay, yeah, go to the tables folder. Yeah, and then can you see employee? Yeah, that one. Perfect. So this is the select style from that. And then I want you to right click. Yeah, just go ahead on the right part and just, oh no, just, yeah, cancel out this one. Yeah, just go ahead and, yeah, okay. Now, once you see that scripting option, that's very important. It will help you build the script and show you exactly how that table was built. I'm not sure the employees table is a very large table. This is taking. Okay, yes, yeah, this is it right here. You see, it begins with create table, the create table, and then you see all the list of columns. This is what we're gonna do in the last week of the training. That's after next week, right? It's good you know how to build a table, right? So this is a script right here, right? And you can see the column name, the data type, the constraint, put a comma, go to the next column, same thing, column name, data type, constraint, right? This is really powerful, right? And all of these things below is just alter statement. We're gonna look at that one as well, right? So this scripting is very, very important. How to script any object, right? It's something that is really small, but it is very, very powerful, right? So everyone should know this. Okay. Thanks. It's Alex. Thanks for that. Lanita, let me share your screen. So mine is still loading. So Lanita, you're going to help us and script out the view we are using in question 2. Okay. Let's see your management studio. Can you maximize it?
I was sleeping.
Oh, I know it's really late for you guys in Cameroon. Yeah.
So I don't even know where I am. Honestly, I was. Hey God.
Okay, no worries. Let me show it on my screen. Just a moment. Okay, mine actually went through, but it took forever to load. So this is exactly the same thing Alex did on the screen to script out the code that was used to create the employee table. So you can see right here is it create table is the name of a table and the schema in which will be stored, and these are the columns. So we're going to see this process later on, right? So I just wanted to understand the focus of this question. There are two tables, right? There's one physical table, which is the employees one, giving us 290 employees. And then there's another one, this view, which is tracking the movement of the employees across the departments. Right, and this is giving us 296 rows. So I think we've done the first part, which is script out the view. In scripting, you simply have to target the database, AdventureWorks, go to the views folder, and then find the view. This is it. V employee department history, and you simply right click on this and go to script, and you can put this on a new query window. Right. This is taking a long time for it to run on my screen. So I'm going to give you the solutions with the steps so that you can create time and go over it. This is very important. Okay, so that's the first part, this part, just the scripting. Now in the second part, this B, show the list of employees, first name and last name, that are in the view above than once. Remember, we just discussed this. The employee department history view is tracking the movement of employees in the same company. So if an employee has changed department 1 or 2 times, you're going to see their ID showing up more than 1 time on this table. But on this table, on the employees table, your ID can only occur once. That's the main table for employees. Your ID can only occur once, right? So they want us to use this view to do that investigation. Show the list of employees, first and last name, that are in the view above more than once. How can you investigate if something is showing more than once in a table? It can be a counting process. So you can decide to do a counting process. And in this counting process, you put each employee, first and last name, combine. Let's try that. Let me first of all give you a strategy. I want to put each employee in one group, in a group, and then count the number of groups. Alternatively, I can just throw in my order by. This is an easy way to visualize, but it's not the final solution. Let's order by business entity ID. You see, if any employee's ID is repeating on this table, then you will be able to see the repetitions when we sort. So if I sort on that and I execute, now this tells me that this employee right here had only one movement, one company, one department. They've been in just one department in the company. They've not moved. And that's why in the department history table, the movement of employees across departments, this person only shows up once. One, you see, this person is the kind of people we're looking. See, this is somebody who has done 2 movements in the company. They worked in the tool design department. They also work in the engineering department. See that? This is very, very important. Right? These are the kind of people who are causing that table to have a higher count. They are the ones responsible for these 296 rows of data in that view, compared to the 290 in the employees table. This is, you see what the power of order by, right? These are the people we want to show. We want to show those individuals who occur more than once in that table. That's the focus of B. So if I put these employees in the same group, individual groups, and I count, this person will have a count of 1, count of 1, count of 1. This person will have a count of 2. I want you to understand where we're going to do this. Every other person is 1, and you can go below and see the next pair. You see, this is becoming challenging. If you have 1 million rows, it will be tricky, but you can do this easily by knowing that if I combine, since I want us to project first and last name, I can concat first and last name. Or let me just show you an easy way. Just give me the business entity ID, right? And then show me counts of the business entity ID. We want to show each business entity ID, and then we count how many times they occur. You saw 4 occurred 2 times. That would be an interesting thing to see. This is the count. And of course, this question will require you to do what? To do a group by. I can keep the order by. Yes, you can keep it. But now I just want to do a group by, because if I run this query, it's going to fail because I have an aggregated, non-aggregated. So the non-aggregated one has to be placed in the group by. This is very important strategy to remember. This is how you count the number of repetitions in a given table. You focus on the key column that is expected to be unique. That's the business entity ID. You group by that column, and then you count the number of repetitions. Now, if I run this, remember business entity ID 4, we saw the 2 occurrences. This is a count, 2. 2 times. Every other one, this is now easy. I can just zoom in and see. I can also just say, you know what, let's order by this. I can change this into what? That is the second column in the list. If I say order by 1, I'm ordering by this. If I say order by 2, I'm ordering by this. And I do, the default is ascending, sorry. I can switch this to what? Descending. So that those employees who are occurring more than one time in that table, they will be at the top. These are them right here. These are the people that are causing that table to have 200. You see, when you do the distinct, you go back to 290. There were 290 distinct employees. But this particular employee has had 3 change in departments in the company. This one has had 2. You see that? So this is now the final strategy. This is one exploration. That's not the final strategy. It's just going to help you to see that. In the final strategy, they want us to show the list of employees, first and last name. So how do I modify this? I'll transform this into what? First and last name. I'm going to put the columns separately, or I can concat. Since we know the power of the concat function, let's combine first and last name into one. I concat first name. What am I doing? How is that stuff reported? Just a moment. Let me go back and explore that table. This is it. Run this. Do we have a first name? So we need the first and the last name. I'll probably have to do okay, I'm executing the wrong table. It should be on this one. Right, this is the one that is going to have the first and the last name. So you see first right here, and then we see the last right here, first and last name. Yeah, so I was on the wrong table. So on this, yes, I can bring in first. So the reason I was getting that error is because of the comma even. Right, so now the first name is pulling up. Put a comma, put a space, a comma, and last name right here. And since I've done this adjustment, I need to also do it on the group by. See, business entity ID is no longer on this part, so I've updated it to a combination of the first and last name. I need to update this as well. Right, and that's the same process right here. So now we have replaced the business entity ID with the actual names, first and last name. That's what the question wants. And this part is just the count, right? We know we technically we don't need that part. It's just to help us visualize this process. Now, if I want to limit this output to only those that have more than one count, what can I do? I need to add the condition. What controls the counts is this right here. See, and since this is a count process in the condition, such a condition goes into what? The haven't clause. So this is how you're going to test how many times each person occurs in the department history table. So we're going to check this and make sure we show greater than 1. All right, let's go back to that question so that we can understand this again. Show the list of employees, that's first and last name, that are in the view above more than once. This is the view of focus, and then this is the counting process of each occurrence more than once. If I remove that condition, I get every person. See, but then we want to only show those that show up in this view more than one, and this is the counting process greater than 1, and this is it. And the question says we should show the first and the last name, nothing more. So this is just extra information we're providing. The main focus of this question was to get the first and the last name of those who fulfill that criteria. They show up in that view more than once. This is very, very important. This test is very, very important. You have to know this, right? So at this point, we no longer need this. That was just to help us, but we need this part, this condition. This part is very important, the grouping, right? And then these are the full names of those who show up more than once in that employee department history table. The focus of that table, this view, is to track the movements of employees across different departments in the company. I remember when we checked out this business entity for this person right here, they've moved 2 times in the company, right? And we saw a good detail of that from let me take out this, and I also take out this, and I add this right here. This is a simple exploration. This is really powerful. It shows you that movement, right? And let's go back to order by 1, so you can see it right here, right? Yeah, you can see this person right here is the same individual. They've worked in the engineering department. They've worked also in the total design department. That's the goal of this table. That's what I've been trying to emphasize on. The V employee department history table is tracking down the movement of employees across different departments. Right. So the more an employee has changed department, the more you will see their business entity ID showing up. So this table is allowed to have repetitions on business entity ID. Meanwhile, the employees table, this one, is not allowed to have repetitions. This explains why there's 290 distinct employees on this table. Meanwhile, there are 296 on this. Right. So this is tracking the history movement of those employees. Those that have changed departments will show up multiple times on this. That's why this number goes up to 296. Right. And now the second part of this question, show us those individuals who are occurring multiple times on that table. You have to do a count on their IDs, make sure you group the names, and this is us rendering that information. 1, 2, 3, 4, 5 individuals have multiple occurrences. And if you're asked now to also add the number of occurrences, that's when you can project this column. Right? They just wanted the names, but if they want to see how many times each of those employees occur, you can then add this column and it will give a much more detailed information. Right? See, this person occurred 2 times in that table. They've changed the departments 2 times, 2 times. But in this question, they did not ask for that fine detail. They just wanted the list of employees, first and last name. So in that case, you can dismiss that counting process on the select, and this is the final solution right here. Any questions so far? So this is just B. Yeah, question.
I have a quick question.
Yeah, question from Alex.
Wait, can you get me?
Yes, we can hear you. Yeah.
Can you get me now?
Yes. Yeah, we can hear you.
Okay.
Yeah, we can hear you.
Okay, what I was saying, what I was going to ask was, because what I thought was, since we're working with subquery, since that's like the theme of this project, of this lab project. So I tried doing this exercise by myself, but then I tried doing it or solving it using subqueries. So I had a very tough time doing that because I thought since this is a subquery team, like the team of the project was subquery, so I
Okay.
thought maybe that was what we're supposed to use. So I had a hard time with that. So is it possible to solve this with subqueries with the subquery as well? Or
Yeah, we can. Yeah, you can solve this with subquery. So in that case, it's going to be a little bit interesting in that. So I can do the investigation. So let me. Yeah, you can break this into a subquery. Let's take the investigation. Let's return. Now in that case, you. Okay. Let's take this. I'm going to take this part and dedicate it to investigation from a subquery. Show me the business entity IDs. So select business entity ID. Show me the business entity IDs of those who show up more than once in the company. This condition is still going to be valid right here. Right. Oops. So what do I have right here? I've changed the, so this right here has to go into this. Right. When building a subquery, you decide how you're going to carve out this the strategy. So I want to reduce this into two parts. So in the first part, my interest would be show me the business entity IDs of those who occur more than once in that table. You see, always remember, guys, the group by in this case is now on business entity ID. We are putting each business entity ID on a group, right? And then we are now adding this condition to show instances where the count is more than one. And so the only thing we get from this process is the business entity IDs. 1, 2, 3, 4, 5. See that? 5 business entity IDs. Right. And that's the same thing you see right here. This is not just an exploration. You see the power of order by. And then since I'm ordering ascending, I can go to the bottom. Oh, sorry. I need to actually go through. This is going to constitute a group. Count is going to be 1. Another group count of 1. Another group. So you see we're grouping by business entity ID. So this is going to be a group of a group of its own. It's only one occurrence, and when we count it, it's going to be 1. Count this 1, 1. This is 2, 1. This person has 2, so these 2 rows will be in one group. When they say group by business entity ID, identical of that will be in a group. As long as you're seeing the same business entity ID, this is going to be a group. And what will be the count? It will be 1. Right. And now show me all those business entity IDs where the count is more than 1. So I'm just showing you an example. 4 right here. 4 must be in this group. Business entity ID 4, that's it's in the group. If I go to 16, let's go back to the order ordering. Let's go down to 16. You see, 16 occurs 2 times. This thing does not lie. You see, it's right here. Now we are fact checking it. Business entity ID 16. This person has worked in the purchasing department. They've also worked in the marketing department. You see, so they show up in that analysis. This is just to verify that what we're doing is correct. All those whose business entity ID show up more than 1, put them together and give me a list of them. And so on. We can also check this one. Check, you see. Now you have this list. Anybody, now this is the second part that is very interesting. Anybody whose business entity ID falls in this list, that's the person we're interested in. Right. And then in the second case, I'm now going to build an outer query. In this outer query, I will use this logic. Now just give me their first and last name. So I'm doing to do select star from. The table is going to be the same, this table. Right. So Alex, this is a strategy for a subquery. Right. And then now how are you going to combine? This is now the parent query. Parent query is giving us everyone. Remember that 296. The subquery is giving us only those who have multiple occurrence, and our interest is what on their business entity ID. You must know what the child query is returning to the outer query. Now we can put a where clause right here to build the umbilical cord. Right? If this is returning business entity ID, we should be capturing business entity ID also So the parent and the child will be connected through business entity ID. So where business entity ID in, why in? Because this is returning multiple. This is a multiple values to test. As long as your business entity ID is on this list, then you had multiple jobs movement, right? So this is going to be an in operator, and that's how you're going to build that. And you block this into this. If I leave it like that, it's going to be very frustrating for you to understand. That's why I like to indent. So I will target my subquery and indent it. So you have to understand that your subquery is investigating those business entity IDs that occur more than once. It gives us a list. This is a list right here. 4, 6. It's like kicking out this, see, and then just putting it where business entity ID in 4, 16, 224, 234, 250. This is it. See, I'm just permitting me to drag this. How did I get this? I investigated this. These are those individuals whose business entity ID occurs more than one in that table. And that's the focus of that question. See? And then from the outer one now, we're going to do a concat of their first and last name. So this is hard coding. This was built from a query. We all know that. I didn't just make up these values. Go fetch the query and put it inside this. Don't give us static values. This is the idea of a subquery. And now on the outer part, we are getting all the columns of those, all the information of those who have multiple occurrences, right? And if you notice, this is going to be giving us distinct, duplicate. So when you're building the concat of the first and last name, like what we did, so this is the part now, I just copy this, right? So all I'm doing, I'm trying to split this query into two parts, one solved by subquery and the other part solved by the outer query, the parent one. So the parent is doing this. Take note, it is wise for you to understand at this point that you're going to be having duplicates. So how do you dismiss the duplicates? Just throw in a distinct right here. We did not need the distinct on this one because we are working on what group by. See? In this one, we need a distinct. As long as the ID is showing up on this list, right? If it's multiple, it's going to show multiple. So you need to embed distinct right there. And this is now the subquery strategy of solving that same question, right? So you will be the one to identify the part that you need to target as an unknown. And then you decide the connection. This umbilical cord thing is very important. A lot of students, this is where I think that's the issue you had in deciding how to frame this into a subquery and then connect it to the parent. That's always the issue. So this connection right here. Yeah, go ahead.
Yeah, that was what I had because I used
Yeah.
instead I used like I tried using the concat function, but then
Right.
it was like completely hopeless. So that's what I struggled with. And also the in, I had no idea I was supposed to use the in. So I
Okay. Yeah.
used equals to instead, so
Yeah.
or
So
equals to or greater than,
yeah, man,
which made it tough.
very important. So usually once you investigate your inner query and you start seeing multiple values being returned, this is what we call in the textbook, in the lecture materials that you have, the multi-value subquery. When the subquery returns multiple values, and that's already a good indicator to know that in the placenta will have in. If you put equality right here, equality is built to test just one value at a time. Right. So this would definitely is a red flag. You see, and they remind you right here, the subquery return more than one value. Right, and that's true. The subquery right here is returning more than one value. Right. So you cannot be using equality to test more than one value at the same time. And that's why the in operator exists to help navigate that. Right. Yeah,
So
this is
then
very yeah.
so the practice is if we have more than two, like more than one value, then we use the in.
Yes.
Oh.
Yeah. And sometimes you may have a one value being returned right here. And then down the line, multiple values are showing up. I've had this problem in the company. I built a subquery, it was just one value that was showing up from this side. So I put equality. And then down the line, a couple of months after, multiple values started showing up from this. So my equality failed because I was supposed to, you see. So I built the query just for that moment. That's why when you're working for a company, think the long term. If this query is giving you a single value, and it will always be a single value based on the business logic, then you're fine, put equality. But if there's any possibility of this query start, running and showing multiple values, then you hard coding, putting an equality right here is going to fail down the line, you see. An in will still work if only one value is being returned from this. Right. So when you're coding in a company, think strategically. Right. But anyway, it's not a big deal. Once it fails, you're gonna figure it out and say, oh, yeah, this is now beginning. This previously was showing just one value. Now I'm getting multiple values. I just need to switch from from equality to in. Right. So I'm going to document this as option 2 for that. Yeah, I think since we're in the context of a subquery, yes, this is a valid way. I'm happy you thought of it from a subquery perspective. So that is going to be option 2. Meanwhile, the straightforward approach without a subquery, is going to be this one. So we can call this option 1. Yeah, I will make sure you have access to this. But let me just go ahead and share this so you can explore. So that's B. And also you see this exploration order by is very powerful. It can help you to, start building your strategy, right? And just by sorting, and you can clearly see that hey, something happened, right? Why is this individual showing 2 times? And then when you go to the department, you see, oh, this is a reason. He was first of all in the engineering department, worked there for a while, and then switch now to the tools design. See, and that's what our table is tracking. The employee department history. See, like your employment history from this period to this period, I work for this company. From this to this, I work for this other company. See, it's tracking the history, right? Okay, I wanted to share something. Oh, that's not complete. So sorry, this is a complete one. But anyway, I will still share the script at the end of the lab so you can have access to it. So that was B. Show the list of employees, first and last name that are in the view above more than once. Yeah. Now show why there are listed more than once. Show why they are listed more than once. It's just a comparison. All right, this is just going to compare the 2 tables we are looking at. So the outer table is going to be based on the bigger one, this one. So to solve this C part, we are comparing this table and this one. All right, let me just copy this 2 and take it to the C part. So it's now a comparison between these 2 tables. All right, so the smaller one will constitute the inner query or the subquery, and the bigger one will be the outer one. So this is the smaller one, and then this is the bigger one with 296 employees, and that's the view. So this one right here is the view, which has 296 employees. All right. So let's see why the difference. Which are those that are year and also year. All right. So I think we've done this part already. This is what we need. This part, we've done this already. This right here. We should do this from, yeah, basically this one also explains that. I think this there's no need to go any further. This is what we need right here. This right here, and I'm gonna just put it right here. And instead of showing this concurrent, this thing, we want to actually see the duplicates. So I'm going to remove this. And basically, you can just dismiss this and put an asterisk right here, right? Because the goal is to show the difference, show why they're listed more than once, right? So we're targeting those that are listed more than once, and we want to show why they're listed more than once. So in the subquery strategy, this is the code we just built above. When we execute this, I want to make sure that yeah, I think it's sorted nicely. All right, so the explanation for this, so this is us showing it, and then we will have to explain it. All right, so the explanation for this, why is this occurring 2 times, for example, is because this employee worked in the engineering department from this date to this date. See, and let me do this. So first, I need to do some sorting. Let's order by the business entity ID. First thing, let's order by business entity ID. And then let's follow this process by ordering with the start date so that I can show you the order of the jobs, the order in which they came in. So now we have this followed by this. Okay, so this is it. So if I zoom into this employee worked for this department, engineering department, from this start date to this end date. See that? I've sorted also by date, by start date. And then second, they also work for the 2 design department from this start date to this date that has not been disclosed. So this explains why this person is showing up twice, because they worked across 2 different departments. If you go to the next employee, same thing. This employee worked in 2 different departments. First, the purchasing department from this start date to this. Next, the marketing department from this start date to this, which has not been disclosed. So this is the showing and the tell of the repetitions, right? This is a very interesting example. Now I think these two this. So William worked for the production first department, next production control, another department. And this explains why they are showing up. See, they will not show up multiple times in the employees table. But since we're looking at employee department history, we are tracking the movements in the different departments. And that's the explanation right there. This is an interesting case. This individual, Sheila, had 3 movements: marketing, quality assurance, purchasing. And you can see the dates right there. So that's how you're going to package this if you want to explain that process. Right. So this is it. So this is the C part. Make sure you have access to this. Okay. So yeah, that's the end of the first part. We have 30 more minutes. Let me just switch to the next part so that we can talk about the stored procedures lab. Please create time and go over this lab sessions. Right. So I'm just going to open the lab for stored procedures. Stored procedure lab right here. Open. So it's still based on AdventureWorks 2022. What's the first question? We are using the salesperson table. So you can just stop right here and just simply run a select star from that table. And right here. Right. So once you know the database has been disclosed, you can just do a select star from the table of interest. It's the salesperson execute. And this is the table we are dealing with. I think we've talked about this table before, like the previous example was based on this table. Okay, so let's see what we have. Now they want you to create a stored procedure called this. The name of the stored procedure has been provided. This is it, without any parameter that will show the sales people the following information. So remember, this is a column, right? Now for the informations to be shown on this stored procedure, business entity ID, this is the column. So we're just extracting this column. This one, this is what we're going to show. Next, commission percent. There's a column called commission percent right here. And they want you to format this column as a percentage to 2 decimal places, right? So let's just get to work. Let me just go to this. Oh, that's a long gap. But anyway, yeah, that's two all right here. Right, so I will just be going back and forth and just extracting the columns, and then we're going to be adjusting them as needed in the business requirement. Right, so let's go back to the list. The first column we have to output is the business entity ID. Right, I'm just going to, I think that they're in the correct order. Yeah, business entity ID. I'm going to put a comma right here. The next column to show or extract is the commission percent, which is this one, commission percent, and they want you to format this as a percentage to decimal place. Remember, there is a format function, and this is really important. I remember I didn't talk about the percentage in formatting. All right, let's just call all the columns and then we're going to format them, and then you see. All right, sales year to date, we're going to format this as a dollar amount as currency. You can do that. All right, so I'm just going to print out them and then show you how to format them. Commission was commission. There's no commission, but I think there's a formula we can use to extract. I forgot to mention that. Right. So commission percent, if you take the commission percent and you multiply it by the sales year to date, this is a commission percent. This is a percentage of this. That's how you get the commission. So this is percent, commission percent, but what is the actual commission is going to be this multiplied by this. I forgot to include that in that process. Yes, so for the commission itself, it's not available, but if you take, so for the commission, this is what we're going to do. You have to take this quantity, that is the sales value the salesperson generated. Your commission is based on a percentage of the work you put in, right? So you're going to take that quantity multiplied by this percentage. This is the, right? And this now will generate the commission. So it's this multiplied by this. This is a percentage. A percentage of what? A percentage of this to get the commission. I forgot to put that description right there so that it's easy. And then finally, get the bonus. This is the bonus column, right? Right. For those who are into sales, most companies like to motivate their sales agent by giving them commissions or bonuses, right? Right. So these are the columns we need. So if I run this, this is just the unformatted versions of this column. Now, commission, let's go back to commission. This is just a number, business entity ID, that's just an ID. We're not going to format that. This, we're told to format this as a percentage to 2 decimal place. Remember, we have the format function. This is how it's written, format. We want to format this as a percentage. Remember, we've seen C for currency, N for number, and I forgot to mention there's a P for percentage. So once you call format and you put P, the system understands that it is going to format this as a percentage. Right. And if you want to actually understand this, then it's good to take the original and then put it next to the formatted one. And you can see the comparison. This is a nice way to learn. If I run this, this is the original column, commission percent. Now this is the formatted one in percentage. Right. And when you put 2 right here, it will project it to 2 decimal place. If you put 1 to 1 decimal place, so the default is 2 decimal place, it stays 2. If I push this to 3, this is how you learn. This is, I just vary that number so that you understand See, it's now going to 3 decimal place throughout. So this is the original column, and this is the formatted part as a percentage too. So P is for percentage, and then this is the number of percentage decimals. See, this is very important. The next you can do sales year to date. We're told to format. So I'm just going to copy this part. Format this as what? As a dollar 2 decimal place. We understand that C stands for currency, and then 2 is the decimal place. That's format. What am I missing? I'm missing a comma right here. See that? If you also want to see the original, this helps in the learning process. Before you format the column, show the original, right? So that you see what has changed. If I run this, let's look at the original sales year to date. This is it. See, now this is a formatted one as a dollar amount 2 decimal places. See, the dollar amount sign has been put, and then it has been transformed to 2 decimal places. This is 5639, 2 decimal place 56. See, this is really, really interesting. And then this also needs to be formatted. This calculation right here needs to be formatted. Right. So let me preserve this original calculation. Right. And let me show you how we're going to format that. So you just simply take the calculation, and then you wrap the format function around the entire calculation. It's going to format the product of this and this. So I close it right here, and then I go in there, put a comma. I want to format it as a currency. Please remember, C is for currency, P is for percentage. And then the 2 there is the number of decimal places. It's good to see the original and the formatted. So we are looking at commission again. This is the multiplication part where you take this multiplied by the percentage. See, this is it right here. The formatted one. This is the original commission. This is the formatted. You have to do this so that you compare. You see, it's nicely done. Right. And we are almost there. The last one we're going to do is the bonus one. Right. Let's get the original bonus. Right. And then we'll get the formatted version. So in this, I'm going to format as bonus as a dollar amount. That's monetary data. Currency 2 decimal place. And let's get a copy of the original bonus column. Right. And then now you can just dismiss those original ones and keep the formatted ones instead of duplicating the column. So for each column, I've shown you the original and the formatted so that you can actually see this is what was stored in the database table. This is what the format function rendered. See the formatting. This is percentage. That's what we put right here. P for percentage, 2 for 2 decimal places. And that's how you study. And you will not forget this. Right. So please, when you're going over these codes, you have to rebuild them, then follow the steps over. Now we can just knock this off as a commission percent. I can now just use this as the aliases. This as that. See, I can now dismiss this. Go to the next. I don't need this. I can use that as the alias. This is the formatted version of the sales year to date as sales year to date. This is that calculation we did. We call this commission. Yes, I'm going to extract that name and put it right here. I'm staying with the formatted version of that calculation. I format this multiplied by this, and that's what we're calling commission. Bonus, I'm going to knock off bonus and keep the formatted aspect of bonus, which is this one. Right, so that now we're dealing with just each column showing up one time and the formatted stuff is right there. This is it. Please practice this. This is very important. Right. So this is what I expected you to do for the A part. Right. That's just a query. Right. Now we have to take this query and transform it into what? A stored procedure. Remember that this is just a query. Now transforming the query into a stored procedure. See, create a stored procedure called this. Preferable. Now I'm just going to preserve this so that you know where this is the query. All right, and now let's copy this. Now creating the stored procedure. So now creating the stored procedure from the query. Creating the stored procedure. From the query. Very important. And how do you create a stored procedure from the query? You simply just add that line above. What's the name of the stored procedure we are expected to create? This is it. Control C and just add it to this line. See, this is the query right here. Just go above it and you add the code. Create. What are you creating? Stored procedure. That's proc or procedure. The name of the stored procedure. And then don't forget the AS keyword. This is it. And sometimes you have this, it just wants you to put a go above so that you separate the syntax into different badge. That's it. That's all you need to create a stored procedure. First is a query. See, so this is the query that has been built. We tested to make sure it's working. So this is the column. So the columns we're going to embed in our stored procedure. We're transforming this now into a stored procedure by simply adding this line above it. And remember, we're not told to put any parameter on the stored procedure. Let's just go back and check. Create a stored procedure called this without any parameters. Yes, that's it. All right, that's A. B, execute the stored procedure. All right, and then C, delete the stored procedure. All right, so this is the end of A. Let's execute the stored procedure. All right, and then now how can we proceed? Let's test the stored procedure. Execute the stored procedure. Remember, stored procedures are not like views. You cannot do a select star from a stored procedure. How do you execute a stored procedure? You use the exec or execute. You can do exec like this, and you put the name of the stored procedure. I always like to do a schema also in front of it. By the way, let me show you where that stored procedure was created. This is the name of a stored procedure. It will be created in this database. So if you want to check it, go to the database, refresh. Stored procedures are found in the programmability folder right here. You'll find them in this folder right here. And you just check the name. The name of the stored procedure we created is sales report year to date. And this is it. It is created in the default schema DBO sales report year to date. If you want to script out or show the script that was used to create the stored procedure, the same thing. Right click, go to script stored procedure, put it on a new query window, and the system will build the script. Yeah, this one. Yeah, right here. So this applies to tables. It also applies to views. It also applies to stored procedures. Basically, anything you see on can be scripted. Any object. Right. So there's no select. That's the error I made. This means that stored procedures are just executed like this. Alternatively, you can type the exec in full, execute. And since the stored procedure has no parameter, you can also simply highlight the stored procedure and click on execute. You see, or you just run this, or you run this. See that? That's it. And then the last part was to drop the stored procedure, right? And that's the C part, right? So dropping the stored procedure, that's the C part. Delete the stored procedure. We talked about this also in class. We just need to use the keyword drop. So if I just put drop right here, this is deleting the stored procedure. Right, it's the same as just putting the keyword drop. What are you dropping? Proc, the name of the procedure. You can also type this in full. Drop procedure system understands that you're dropping a stored procedure. And these are several lists of stored procedure on the database, which is a specific one you want to drop this one. I just simply go ahead and click on execute. Before executing it, let me show you. This is it right here. Now let's drop it. It's right, it's still there, but then that's just the remains. You have to just refresh the folder. Right, and now it's gone. See, it was the first stored procedure, right? It's gone. We've dropped it. See? So that's what we expected to do for that first question right here. Creating the stored procedure, right, executing it, deleting it. Right, that's it right there. Complete question 1 above before attempting this. So this is just a continuation. In this example, you're just going to create that same stored procedure, this time with a different name, right? And the goal is that you want an individual to provide their business entity ID for the stored procedure to execute. So this stored procedure will use a single parameter, and it will be a business entity ID as a parameter. Right. So this is very important. It's the same logic. This is it. For you to see this report, they want you to provide a business entity ID so that you can only see your individual value. This is very important. These are confidential information in a company. Right? So the salesperson will come in and log in with their business entity ID, and they'll only be able to see this. This is my year-to-date sales. This is the percentage commission the company is giving me, and this is the commission I'm getting, and this is the bonus. You see, so these are confidential information. See, when it comes to bonus and commission percentages, these are confidential information in company. So what we did in this first part, the stored procedure, once you call it, it just shows everything. That's not good. Right? Each salesperson should be able to view only their information. Right? So this is what we're gonna do to build that process. We have to use this same logic, right? Copy that logic, and this time around we're gonna build it so that it uses everything I explained is in this explanation right here. The reason, the motive of doing the stored procedure, which is going to run on the parameter, is going to be the same logic, so that every person can only view their own bonus information, commission percent, and stuff like that. It's a confidential information. So you must provide a unique business entity ID for you to see the outcome. All right. So in the first solution, that's for A, it's all about creating, that's using that same logic, but this time around we're creating a new stored procedure called this, that's the A, with a parameter called this. This stored procedure now has a parameter. So we're gonna attach this right here to the name, create procedure. This is it. And how do you add a stored procedure? How do you add a parameter to a stored procedure? This is a name. You must attach the at symbol, this, and you must disclose this as an integer. So every parameter must have a name with this symbol in front of it and the data type. See, the business entity IDs are integer, you can see from this table. So these are the values we'll be passing before we can see the content of the stored procedure. All right. And now we need the AS keyword right here. See that? And when you see this, it's just a matter of going above and making sure you have a goal so that this becomes the only statement in that batch. Right. So this is us creating a new stored procedure called this, which uses this parameter. And when you create a stored procedure, make sure you use it to filter. When you create a stored procedure with the parameter, make sure you use the parameter to filter the stored procedure. So this is going to be based on what? By you passing in a valid business entity ID. So where the business entity ID will be equal to whatever value you pass when you call the stored procedure. So always use the parameter you've created to filter the stored procedure. This is very important. You're going to test that in the next set of questions, these values. So each time we call the stored procedure, we'll provide one of these, and that's what it will be placed right here. This is just a container. When you call the stored procedure, you provide a value. This value will now go into this query and be placed right here. The query will be executed to just give you that particular business entity ID. See? So this is it. This is the full step, creating the stored procedure, execute. The stored procedure is created. We can go and check it. Let me refresh the folder. This one is called business sales report year to date business entity ID. This is it. Sales report year to date business entity ID. That's it. That's it. Now the next part is easy. They want us to test a couple of values. Execute the stored procedure for business entity ID. So we have to run them one after the other. Right. So once the stored procedure has a parameter, when you call that stored procedure, you have to specify the value. So if you just call the stored procedure like what we did previously, we just do an exec and you put the name of the stored procedure. Guess what? It's no longer going to be valid. Right, this is what we did in the first example. It never had a parameter, so you had to execute like this. We had an error. We have an error because the stored procedure has a parameter. See, this is why we're having this error. Procedure, this is expects a parameter. So some people actually type in the name of the parameter like this, right? What's the name? This is a business entity ID, and they put the value this equal this. Was the first value to be tested? This one. So that's the first value to be tested. Some people do this, right? And this is still valid. If I run this, you see, now you see I get only the rows for that particular business entity ID. And this is something very important. That's what they try to explain right here. In question 1 above, when we execute the stored procedure, it shows all the sales information for each business entity ID. Let's assume this information is highly sensitive and each salesperson should only know their unique business entity ID. Right? So if this is my business entity ID as a salesperson, I should be able to call that stored procedure and provide that ID. And guess what? The stored procedure will only show me the sales information, bonus information for my particular case. I'm not able to see what others got. See, this is very important. See, we are treating this as confidential. Right. So that's one way to do this. Another way is just to call the stored procedure, right, and just put the ID next to it. You don't need to always call or specify that parameter. So the next value to be tested is this. I'm just going to copy all these next values. And each of them, we're going to run the stored procedure and test against it. So that's the first one. This one, you see, I just need to put that name and execute. I don't need to specify this equal to this. I can do this, you see. The next one, Control C, just paste. I'm going to paste it right here. See, and call this. This is us testing the stored procedure against each of those values. And you see, at each run, we are only seeing one row, right? And the information we get is the bonus and commission information for that particular business entity ID. See, so other salesperson will not be seeing the numbers of other salesperson. You only see your number. See, these are confidential information. Right, that's the power of a parameter embedded in a stored procedure. Right, so this is very important. Right, so that's the B part where you just run all those executions. In the C part, delete the stored procedure. I think we've done this before. I'm going to put the C part right here just to delete. Right, so to delete the stored procedure, you have to just copy the name of the stored procedure. Right, and you put the keyword drop. Yes, what are we dropping? Are you dropping a table, a view? No, we are dropping a procedure. And this is the name of the specific procedure we want to drop. And once you execute this, that stored procedure goes away. This is it right here, still exists. If I refresh, I still see it. I've not yet dropped it. See? Now, if I go ahead and drop it, it's gone. The query was executed successfully. I can just go right here and refresh the stored procedure folder, and you will not see that it's gone. See? Right. Okay, I think we're going to stop right here. I will give you question 3 to work on. Right, so this is the base query you're going to start. You're going to start with this, and then you add the required columns just like what we did. Right, these are the required columns to be added. So you're starting with this query right here. You execute this query, and then you start adding the columns. So how we built the previous one. You add each of these columns. See? And follow the instructions. This one says full name, so first and last name has to be concatenated. Right. So yes, I want us to end right here. I will provide the script for the solution, but please work out question 3 for the stored procedure. I will check it during the next class. Right. Okay, any question before we go? Okay, see you guys on Saturday. Good night, everyone.